Have you ever wondered what happens with waste after you throw it in the bin? In this video, we'll follow plastics and biomass through three key steps: collection, sorting, and pretreatment. This is the front end of the solid waste management system. And if the front end fails, even with the best technology at the back, we will struggle. No technology works well with random mixed waste. So to make waste usable, three front-end steps are crucial. Collection. This is a step where waste is picked up from where it is produced and brought into the waste management system. Sorting. Separating waste into fractions by material type. Pretreatment. Preparing it for composting, anaerobic digestion, thermochemical conversion, or recycling. Separating waste properly makes recycling work better and increases both the quality and the amount of material that can be recycled. So let's start with collection. Collection is not just picking up the trash. It's the first sorting stage of the whole system. In many high-income countries, municipal solid waste organics go to separate biobins or into mixed residual waste. In the case of plastics, these are collected through various methods, like curbside pickup, specialized return systems, and deposit refund programs. However, in many parts of the Global South, most waste is still collected as a mixed stream. Plastics are often recovered by informal waste pickers, and agricultural and forest residues are mainly openly burned. How collection is organized through formal services and informal actors determines contamination levels, particle size, moisture variability, and feedstock homogeneity. These conditions, in turn, determine which valorization options are techno-economically feasible at scale. Once waste has been collected, it usually goes through sorting, either at the source or at the facility. At the source, households and businesses separate organics, recyclables, and residual waste. This matters because clean organics make better compost and biogas, and clean plastics are easier to recycle. On farms and in forests, residues like straw, prunings, and branches are also separated from the main product and roughly cleaned to remove soil, stones, plastics, and other inert materials. This is done by using sieving, screening, and manual checks. At sorting plants, much more detail is added. For plastics, waste moves on conveyor belts where several technologies exist nowadays to split them into separate streams. These range from manual dismantling and picking to automated processes such as shredding, sieving, air or liquid density separation, magnetic separation, and sophisticated sorting technologies such as UVVs, NIR, or laser optical sorting. Today, some sorting plants are very efficient on addressing contamination and increasing the quality of the sorted material. For example, Site 0 in Sweden uses about 5 kilometers of conveyor belts and 60 NIR sensors to sort up to 95% of plastic packaging for recycling, with over 90% purity in single plastic fractions. Other examples include AMP1 near Cleveland, which uses AI-based sorting to recover most materials with more than 95% uptime. Now let's look at pretreatment. Pretreatment is all about preparing the waste so that it can enter a specific technology efficiently and safely. For biomass, common pretreatment steps include size reduction. Particle size requirements depend on their intended use in different conversion technologies. For example, agricultural and forest residues are typically shredded to 20 to 30 millimeters for anaerobic digestion, and down to 0.6 to 0.87 millimeters for pelletizing, or to 0.2 to 1.5 millimeters for gasification. Mechanical size reduction makes it easier to feed the material into the different technologies and improves heat and mass transfer. If the particles are too big, the inside stays cooler than the outside, so they do not heat evenly. In the next step, stones, metals, glass, and plastics are removed by screening and separation to avoid damaged equipment or reduce process efficiency. Freshly harvested biomass typically has moisture contents between 60 and 75 weight percent. Technologies such as drying or torrefaction can be used to dewater it and improve the quality of biomass. These pretreatment processes can decrease the biomass moisture content to 8 to 10 weight percent before it is used in thermochemical processes. Pretreatment for plastics looks different, but the logic is the same. First, plastics are sorted by type as much as possible. For example, PET bottles, HDPE containers, and flexible films. Next, plastics are cleaned and washed to remove food, residues, labels, and dirt. After the plastic is sorted and cleaned, we can cut it into small flakes or melt it to make pellets. Then, these flakes or pellets are used to make new products. Densify or pelletized mixed plastics can be used as feedstock for thermochemical conversion and other chemical recycling routes. Some types of plastics in mixed waste are very difficult to sort and recycle with conventional methods. In these cases, advanced recycling technologies can help keep more plastics in the loop instead of sending them to landfill or burning them. It is important to mention that collection, sorting, and pretreatment faces many challenges. For example, if households don't separate waste correctly, contamination increases. Sorting plants, collection trucks, containers, and pretreatment equipment are not cheap, especially for low-income regions. There are always choices to make. Better sorting and pretreatment cost more money at the beginning, but they give cleaner waste streams, so advanced technologies work better and can be more profitable.